Hello there. Welcome to Sleep Theory, your quiet space at the end of the day where science and storytelling drift together like clouds across the night sky. Before we begin, I'd love to know where in the world you're listening from tonight and what time it is where you are. Share it in the comments if you'd like. I'm always amazed at how many of us gather here from so many corners of the globe. And if you enjoy these gentle journeys into science and sleep, a like or a subscription helps this little corner of calm keep growing and helps more wandering minds find their way here. So now, if you'd like, you can dim the lights, let the room settle into quiet, maybe switch on a fan for that gentle background hum. Together, we'll ease into our journey through the multiverse. And if your thoughts begin to wander along the way, that's perfectly all right. Just let them drift where they will. This story will be here, unfolding softly in its own time. Let's begin not with equations or hypotheses, but with something smaller, something familiar. You're standing in a grocery store aisle. Your left hand holds a box of cinnamon cereal. Your right grips something chocolatey and indulgent. You pause, imagining the taste, the crunch, maybe even the guilt. Then, without ceremony, you decide. One box returns to the shelf, the other settles into your cart. You move on. Seems trivial. But now picture this. What if the other version of you, the one who chose differently, didn't vanish? What if, somewhere, another reality unfolded? One where the chocolate cereal came home, and tomorrow's breakfast tastes just a little sweeter. A tiny difference, a faint ripple, yet multiplied across every choice, every fork in the road, every missed train, every unopened message, every door entered or ignored. Suddenly, it isn't just one life branching, it's an entire forest of possibilities. And in that whisper lies the multiverse. Now, the multiverse isn't merely science fiction, though it inspires brilliant stories. It's an idea that rests in the strange meeting place of quantum physics, cosmology, and imagination. Some scientists suggest it may not just be possible, but perhaps even necessary, that the universe we see, vast and beautiful as it is, could be only one among countless others, all part of a greater, stranger reality we can barely begin to glimpse. It's not the easiest thought to carry late at night. Our minds are tuned for a simpler kind of world, one with firm ground underfoot and steady rules of cause and effect, where the sun rises each morning and the socks you put in the drawer stay obediently in their place. And yet, even that simple world slips from certainty when we look too closely. Quantum physics whispers that particles do not always behave, that light can be both a wave and not a wave, that at the smallest scales, certainty dissolves into probabilities, like a coin that never lands but spins forever in the air. The multiverse asks us to wonder, what if instead of choosing heads or tails, the universe quietly answers yes to both? In one version of reality, you close this video right now and drift into sleep a little earlier than planned. In another, you stay awake just a while longer, curiosity nudging you forward to see where this story might go. And in yet another, you're not here at all. You're somewhere else entirely, perhaps walking along a beach, sitting at work, or in a place you couldn't even name if you tried. Each choice you make stretches outward like the limbs of a great tree, and each branch carries a version of you, shaped by winds that blow in slightly different directions. But why would scientists, of all people, those often seen as the guardians of reason, precision, and clarity, entertain an idea as strange and dizzying as this? The answer is that science doesn't set out to be strange. It sets out to be faithful to what the evidence reveals. And sometimes that path leads into landscapes that feel more like dreams than equations. In quantum mechanics, one of the most successful and yet baffling theories of physics, there lives a puzzle called the measurement problem. Put simply, until a particle is measured or observed, it does not sit neatly in one place. Instead, it hovers in a haze of probabilities, a superposition, both here and there, both yes and no, a coin forever spinning in the air without landing. But when we measure, when we look, something peculiar happens. The haze collapses, the particle seems to decide, and the world moves forward with one result. The many worlds interpretation dares to suggest something different. What if there is no collapse at all? What if every possibility happens? One universe where the particle lands here, another where it lands there. One universe where the cat breathes quietly in its box, another where it does not. One universe you blink, another where your eyes stay open just a little longer. Each outcome branching, endlessly, quietly multiplying reality itself. It's not the only interpretation, but it is one that doesn't require collapsing the wave of possibilities. It keeps everything, every outcome, every moment wasted, no choice erased, just multiplied. Now maybe that sounds dizzying, but it can also be strangely comforting. If every possibility unfolds somewhere, then maybe we're never really trapped by the choices we make. Maybe every version of us gets to try a different path, to follow a different dream. Maybe the lives we let go of still play out in some parallel rhythm, dancing just out of reach. Of course, we can't test this easily. We don't have a telescope that peers into other universes. Not yet. Maybe not ever. But the math, the logic, and the quiet elegance of the idea, it calls to something deep in us. The same part of us that wonders who we might have been had we turned left instead of right. Had we said yes or no, or nothing at all. So as you settle deeper into the quiet of your evening, let the idea unfold softly in your mind, not as something to solve, but as something to sit with. Like mist over a field, like a thought slipping away as you begin to fall asleep. Maybe you're not alone in this moment. Maybe somewhere else, another version of you is listening too, just a heartbeat out of sync. Another you still wondering, still reaching, still dreaming. And maybe that's the secret of the multiverse. Not that it's real in the way bricks and chairs are real, but that it gives us a way to imagine without limits. A way to see ourselves not as a single line, but as a constellation. Imagine yourself standing at the edge of a vast ocean. Not the kind you see in postcards or travel shows, but something far larger, quieter, and stranger. There is no horizon, no sun to shimmer across the surface, no wind to push the waves, just a soft, endless expanse rippling gently in all directions. Now imagine that scattered across the surface are bubbles, countless and constantly forming, some tiny, others immense, rising into being with barely a sound, then drifting, colliding, or slowly expanding until they vanish from sight. This ocean, in the imagination of some cosmologists, is space itself, and those bubbles, entire universes, each with its own version of reality. Perhaps one of them is ours. This is the idea of eternal inflation, a gentle but radical proposal about how the multiverse might be born. And like many big ideas in cosmology, it begins with something incredibly small. Right after the Big Bang, or what we perceive as the beginning of our universe, everything was unimaginably hot, dense, and compact. But rather than expanding at a steady pace, this early universe went through a phase of extraordinarily rapid growth, a kind of runaway stretching called cosmic inflation. In less than the blink of an eye, space itself expanded faster than the speed of light, smoothing out its wrinkles, stretching quantum fluctuations into the seeds of galaxies, and setting the stage for everything we know today. But here's the twist. In some versions of inflation theory, this runaway expansion never completely stops. It might slow down here and there in pockets, giving birth to local universes like ours. But the larger process, the stretching, the bubbling, the foaming of space, continues eternally elsewhere. That means while our universe cooled, settled, and began forming stars and atoms and cozy living rooms, other regions of this cosmic ocean kept expanding, kept forming new bubbles, each one potentially a brand new universe, disconnected from ours, sealed off by vast inflating distances. That's where the term eternal inflation comes from. And while it might sound poetic, it's actually the mathematical outcome of how inflation might behave under quantum conditions. According to this view, universes are not rare, they're inevitable. The formation of a universe is not a singular miracle, but a natural ongoing feature of the greater cosmic landscape. Each of these bubble universes could be profoundly different from ours. Some may have more dimensions or fewer. Some might have gravity that's stronger or weaker. Some might not support atoms at all. And in some, the laws of physics might be so alien, so utterly different that even the word universe might feel a poor translation. In our bubble, the sky looks blue. Light travels at a certain speed, and electrons dance in tidy orbits around atomic nuclei. But somewhere else, light might behave more like a liquid, or never form at all. It's hard to picture. We are, after all, creatures evolved to survive on a single planet, orbiting a single sun. Our minds aren't built to handle infinities and eternities. And yet the more we learn about the cosmos, the more it seems that infinity is not just a number, it might be the backdrop to everything. To make this a bit more approachable, let's use a soft analogy. Imagine you're baking bread and the dough is rising. As it expands, little pockets of air form inside, tiny bubbles trapped within the soft structure. Some are round, others misshapen. Some grow large, others stay small. If you could shrink down and step inside one of these bubbles, you'd experience your own enclosed world, unaware that just a few millimeters away, another pocket is growing with its own shape, its own character. Now stretch this idea across cosmic scales, and you have something resembling the eternal inflation model. You, in your pocket of reality, can't see the others, but they're there, separated not by walls, but by expanding space itself. And just as you can't move from one bubble of bread to another without breaking the structure, we can't easily visit other universes. In fact, many physicists believe it may be impossible. The inflating space between bubbles stretches so rapidly that it outruns any possible signal, any light, any ship, any probe. If you tried to go there, you wouldn't just be moving through space, you'd be chasing something that retreats faster than you could ever catch. Still, the idea lingers gently, quietly, a background hum in the minds of those who study the deepest architecture of reality. If our universe is just one bubble in a cosmic foam, then everything we observe, the galaxies, the stars, the laws of physics, may be just a local condition, a regional dialect spoken by this corner of the multiverse. Elsewhere, the language is different. Some physicists even wonder whether this might explain some of the fine-tuned features of our world. The fact that gravity is just strong enough to hold galaxies together, but not so strong that everything collapses. That the charge of the electron is exactly what it needs to be for atoms to form. that the expansion rate of the universe is not too fast and not too slow, but just right for stars and planets to emerge. It's as if the universe is delicately balanced, as if it was made to be habitable. Or perhaps, say proponents of eternal inflation, it's not that this universe is special, it's that there are so many universes, such a vast and varied collection that some of them were bound to get the recipe right. We are here not because the universe is fine-tuned for us, but because in this one life can ask questions, and so we ask. As you rest tonight, and your breath softens, and your thoughts begin to drift, let yourself imagine this cosmic sea bubbling gently, endlessly, beyond the reach of light or sound. Picture the foam of newborn universes rising slowly in the dark, each one trying its hand at existence. Somewhere out there, perhaps, is a universe where you never stopped painting, one where dinosaurs still roam, one where time flows backwards, one where stars sing. Not because it must be so, but because in an infinite canvas, perhaps every color finds a place to shine. Close your eyes for a moment and imagine standing at a crossroads, not a busy intersection or a map-marked trailhead, but something quieter, softer, a place where the road behind you gently dissolves into mist, and before you lie two winding paths, each leading into a future you can't quite see. You stand still, weighing one choice against another. Maybe you move left, maybe you don't. But now imagine that you did both, that you followed one road in one world and the other in a different one. You didn't decide between them, you simply split. Not metaphorically, but quite literally. Two versions of you, each walking a different future, unaware of each other, but equally real. This is the heart of the many worlds interpretation of quantum mechanics, one of the most fascinating and gently unsettling ideas in all of physics. It proposes that every time a quantum event can go more than one way, it does, and the universe doesn't choose a single outcome, it branches. At the smallest scales of existence, far smaller than a grain of sand or even the cells in your body, particles behave in ways that defy our everyday understanding. An electron, for instance, doesn't orbit a nucleus like a planet around the sun. Instead, it exists in a cloud of probabilities, a blur of potential positions until something, an observation, a measurement, forces it to settle on one. This is what's known as superposition. The particle is not here or there, it's everywhere it might be until it must pick a spot. But the many worlds interpretation, first proposed by physicist Hugh Everett in the 1950s, offers an elegant, if wild, alternative. The particle doesn't collapse into one state. Instead, reality itself divides. In one universe, it lands here. In another, it lands there. And both outcomes unfold, not in competition, but in parallel. Extend this beyond particles, and you reach something far more personal. If your neurons, your thoughts, your choices are shaped by quantum events, then you too may branch. In one world, you say yes. In another, no. In one, you keep walking. In another, you turn around. And all of them are real. Each path leading to a different future with a different you shaped by that one quiet decision. Now, this isn't something you'd notice. You wouldn't feel the split. You wouldn't see the other you waving from across the divide. The branching is seamless, invisible, woven into the fabric of the quantum world. From your perspective, only one outcome plays out. But behind the scenes, reality is not choosing. It's multiplying. To illustrate this in a gentler way, imagine a vast library. Each book on its shelves is a version of your life, a different draft, a different title. Some are short and strange, others long and beautifully complicated. You live inside one volume, turning its pages one at a time. But on those quiet high shelves, the others remain, full of the chapters you didn't write, the lives you didn't live, not erased, not lost, just unread, yet still real in their own quiet way. The many worlds interpretation doesn't require magic. It doesn't break the laws of physics. In fact, it follows them mathematically, logically, without the need for special observers or collapsing wave functions. It treats the universe as a grand quantum system, evolving smoothly and deterministically. But because we are observers within the system, we experience the world as if choices are made, as if one future unfolds while the others disappear. We only see one thread at a time, and yet perhaps we sense the others in dreams, in memories that don't feel quite right, in moments when we hesitate, feeling like we've already been here, already done this, already lost or gained something we never actually touched. Perhaps it's just imagination. Or, perhaps in some subtle, ineffable way, the other branches whisper across the divide. Some physicists dismiss this interpretation. It's elegant, yes, but untestable, at least for now. If these parallel universes exist, they don't interact with ours. They don't send messages or leave footprints. They're like ghost ships sailing forever on parallel seas, each with its own crew, its own course, its own story. We are passengers on just one of them, staring out into fog, wondering what lies beyond the rail. And yet the idea lingers, not because it gives us control, but because it offers possibility. In a world that often feels narrow and deterministic, the multiverse reminds us that the story could always unfold differently, that every what if isn't just a question, it might be a place. What would it mean to live like that were true, to walk through your day, knowing that every moment branches, not as a burden, but as a kind of grace, that each version of you gets to try, that no choice is wasted, no path is truly closed. Maybe in another universe, you never left your hometown, or you moved across the world. Maybe you became a teacher, or a dancer, or someone who always wears yellow. Maybe your greatest fear in this life is your greatest joy in another. Maybe you're already living the version someone else only dreams of. It's not something we can prove, but it's something we can feel, not as a scientific conclusion, but as a poetic truth. So tonight, as you drift toward sleep, think not just of the day you lived, but of the many versions that might have been, the roads not taken, the words not spoken, the lives you didn't live, but somewhere maybe you did. You're not just a single thread, you're a tapestry, and the universe, perhaps, is still weaving. Picture the universe as a vast stretched sheet, like an enormous fabric laid out under a sky you can't quite see. That fabric is space itself, and though it may look smooth and still from far away, if you lean in closer you'll notice it bends. It sags gently around heavy things like stars and planets, and warps slightly in the presence of motion and energy. This bending, though invisible, is what we feel as gravity, not a force pulling down, but a quiet invitation to follow a curved path through space. Now imagine taking that sheet and folding it, not in a rough, crumpled way, but with care, as if you're tucking the edges together. 2 points, once far apart, are suddenly close, almost touching, and then imagine drawing a tunnel from one point on the folded surface to the other, bypassing the stretch in between. That tunnel, if it could exist, is what physicists call a wormhole. Wormholes are not just the stuff of science fiction, they're genuine solutions to Einstein's equations of general relativity, mathematical possibilities tucked deep within the way space-time is shaped. The name wormhole itself comes from a simple image. Imagine a worm crawling across the surface of an apple. It could travel all the way around the outside, taking the long route, curving slowly across the skin, but it could also, if it chose, burrow straight through. Same destination, less distance, a shortcut through the inside. In physics, the idea is similar. A wormhole could connect two regions of space that are far apart, not by shrinking the distance, but by creating a new kind of passage, a tunnel, outside the normal fabric, linking points in a way that bypasses the in-between. Of course, as elegant as that sounds, the reality, or rather the theory, is more delicate. Wormholes, if they exist, would likely require something strange to keep them open. Ordinary matter, the kind that makes up stars and tea kettles and sandwiches, wouldn't be enough. It would collapse the tunnel like a paper straw. What's needed instead is something exotic, matter with negative energy or negative mass, capable of resisting the tunnel's natural urge to pinch shut. We've never seen such matter directly, but the equations allow for it, and in physics, that's a door. Some theories suggest that microscopic wormholes could pop in and out of existence constantly at quantum scales, tiny threads blinking into reality and vanishing just as quickly. Others propose that a massive wormhole might exist near a black hole or even inside one, though accessing such a thing, if it's even possible, remains purely theoretical. It's important to be clear here. No one has observed a wormhole. No telescope has found one glowing faintly between stars. They remain mathematical shadows, elegant, consistent, but unseen. Still, the idea is compelling because it offers a possibility we rarely consider, that distance as we know it might be something we can bend. And it raises a quiet question: what else might we bend? In some solutions to Einstein's equations, wormholes don't just connect places, they might connect times. A traveler who enters one end might emerge not only somewhere else, but somewhere and a when, as much as a where. Now, this is where things become tangled, not just scientifically but philosophically, because time in relativity is not separate from space. It's part of the same structure, a woven fabric called space-time. And just as we can fold space in theory, we can fold time. A wormhole could be a bridge not just through galaxies, but through eras. It's difficult to know how seriously to take such possibilities. They live on the edge of known physics, in a place where our understanding is still blurry and incomplete. But they are not fantasy. They are ideas born from the same equations that describe the orbits of planets, the bending of starlight, and the expansion of the universe itself. Perhaps the most fascinating thing about wormholes isn't their potential as cosmic doorways, but what they tell us about the universe, that space is not fixed, that the distance between here and there may not be absolute, that shortcuts could exist, hiding in the folds, not in violation of the laws of nature, but as part of them. For now, they remain hypothetical. We have no technology to create one, no method to hold one open, and no guarantee that they are anything more than beautiful solutions on paper. But then again, many things in physics began that way. Black holes, once just mathematical curiosities, are now observed realities. Gravitational waves, once considered nearly impossible to detect, have been heard echoing from colliding stars. Maybe one day, a whisper in the dark will become a door. Until then, the idea lives in thought experiments and in quiet wonder, in movies and dreams, and in the pages of speculative papers. We walk through our days assuming that here and there are separated by space, and that space is something we must cross. But what if that's not always true? What if folded in the structure of the cosmos, there are bridges waiting to be found, thin threads strung between the stars, humming softly with possibility? As you lie there drifting deeper into the rhythm of breath and stillness, imagine that thread, not loud or glowing, but silent and hidden, a space bridge gently sleeping between two corners of reality. Maybe it stretches from one galaxy to another. Maybe it links your bedroom to a point in deep space. Maybe it's just a metaphor, a thought, a path the mind can walk even if the body cannot. Tonight, you don't have to travel. You can simply rest, knowing that somewhere in the equations of the universe, shortcuts are allowed, and that's enough. Time, for most of us, feels like a river. It moves in one direction, quiet, steady, unstoppable, from sunrise to sunset, from breath to breath. It carries us forward, never back. You wake, you act, you remember. The past holds your stories, the present holds your choices, and the future, like a foggy road, holds your questions. But what if that river wasn't quite what it seemed? What if time could curve, twist, or even loop? And what if, under certain strange conditions, it might be possible, not in fantasy, but in physics, to step off the riverbank and walk upstream? This idea, at once breathtaking and bewildering, lives quietly inside Einstein's general theory of relativity. His equations, which describe how gravity works by warping space-time, allow for some peculiar solutions. Mathematical worlds where the fabric of reality is not just curved around stars and planets, but folded in on itself. In some of these solutions, if the conditions are just right, it becomes possible to follow a path through space and time that loops back to its own beginning. These paths are called closed time-like curves, and they suggest that, at least in theory, the universe might allow time travel. Now, to be clear, this is not the time travel of popular films, where you can dial in a year and leap into the past, like stepping off an elevator. It's subtler than that, more abstract and difficult to grasp. A closed time-like curve is a kind of loop in space-time, a path that winds forward locally, but ends up back where it started globally. If you were riding such a curve, you'd never feel like you were going backward. You'd simply continue forward and eventually arrive at a moment you had already lived. It's a strange concept, made stranger by what it implies. Because if time travel into the past is possible, even in theory, then so are paradoxes. Take the famous grandfather paradox. Suppose you travel back in time and accidentally or deliberately prevent your grandfather from meeting your grandmother. Without that meeting, you're never born. But if you're never born, then you can't travel back in time to interfere. And if you don't interfere, then your grandparents do meet and you are born, but then you go back and the loop continues. It's a knot in causality, a logical tangle that seems to defy reason. To resolve these paradoxes, physicists and philosophers have proposed many ideas. One of the gentlest is the notion of self-consistency, that even if time loops exist, events within them must be self-consistent. You can go back, but you cannot change the past in a way that prevents your own journey. Whatever you do was always part of the timeline. It's not a free rewrite, it's a closed script. There's also the possibility that any change you make by time travel might cause the timeline to split. This brings us back to the multiverse idea. Perhaps every change you make creates a new branch, a new version of events where both outcomes coexist in parallel. One where you prevented the past and another where you didn't. Neither cancels the other, both unfold. But stepping back from the math, there's something more delicate to consider, something human. Because even if we can't build a time machine, our minds are already time travelers. We revisit the past in memory, relive moments in dreams, and leap into imagined futures with every plan we make. The mind doesn't obey the clock. It slips, it spirals, it returns to the places we thought we'd left behind. You're lying in bed and suddenly you're 10 years old again, holding a sun-warmed stone in your hand. Or you're picturing next Tuesday, already feeling the conversation you haven't had yet. The body is still, but the self is moving. Sometimes late at night, memory and imagination blur. Was that a dream? A memory? A feeling borrowed from another life? We say things like, "It feels like déjà vu," or "I've been here before," even when we haven't. Perhaps it's just a brain quirk, a misfire in the circuits of recognition. Or perhaps it's something deeper.
A resonance across time, a loop, softly felt. Time in the universe we know is intricately tied to space. The faster you move through space, the slower time flows for you. We've measured this with satellites and atomic clocks, watched it play out in the faint slowing of time for astronauts orbiting Earth. The effect is tiny at our scale, but real. And it means that time is not fixed. It bends, it stretches, it responds. So when we ask whether we can travel through time, perhaps the better question is, how flexible is time really? Can it fold back on itself like space does? And if so, what would that mean for us? Perhaps there are regions of the universe where space-time is twisted just right, around massive rotating objects, or within strange geometries of energy, where time loops become more than math. Perhaps someday we'll find those places, or build them, or fall into them by accident, the way light vanishes into a black hole, unaware of the edge until it's already crossed. But for now we live in the forward flow, day into night, cause into effect, breath into breath. Still, it's comforting to know that the equations, those quiet, elegant rules beneath reality, leave room for the extraordinary. They don't demand time travel, but they don't forbid it either. And that's enough to wonder. So tonight, as you drift between one moment and the next, between the quiet of now and the dreams of what comes after, imagine time not as a line, but as a loop. Imagine that every memory is a touch point, every dream a tether, that the past isn't gone, it's just out of reach, waiting on the far side of a curve. And maybe, just maybe, time isn't a river at all. Maybe it's a circle drawn so wide we mistake it for a straight path. Somewhere in the dark beyond our skies, scattered across the vast canvas of the cosmos, there are places where light has given up. Not because it was extinguished, but because it was trapped, held in by gravity so intense, so quietly absolute, that even photons, the swiftest messengers in the universe, cannot escape. These places are black holes, and though they are among the most mysterious and extreme objects we know, they're also among the most elegant. In their silence, they speak to the deep structure of space and time. In their stillness, they reshape everything around them. To most of us, the term black hole evokes an image of emptiness, a void, a tear, a place where things vanish. But a black hole is not a hole in the usual sense. It's not a tunnel or a drain or a doorway, at least not in the way our senses understand. It's a region of space where gravity has won, a place where the mass of a collapsing star or the merging of many stars has been compressed into such a dense point that the surrounding fabric of space-time folds inward completely, not with violence, but with inevitability. At the boundary of a black hole lies the event horizon, a name that sounds almost poetic. It is the line past which no information, no light, no signal can ever return to an outside observer. Anything that crosses this boundary fades slowly from view, stretched and reddened by gravity's relentless pull until it becomes invisible. But from the perspective of something falling in, the experience is stranger still. There is no bump, no jolt, no sign that the line has been crossed, just a quiet fall toward a place where the known laws of physics dissolve. At the heart of every black hole, or at least in the center of the classical model, there is something called a singularity, a point of infinite density and zero volume, where gravity becomes infinite and the equations that describe space and time simply break down. It's not that the laws stop working, it's that they stop being able to describe what's there. It's a mystery wrapped inside mathematics, a question mark in the shape of a point. But here's where things become more curious. Some physicists have wondered if a black hole is a region where everything falls in and nothing gets out. Might there be an inverse, a region where nothing can enter and everything is pushed outward? This hypothetical counterpart is known as a white hole. If black holes are entrances, deep gravitational wells pulling inward, then white holes are the opposite, outflows, erupting matter and light outward with no way back in. There is no direct evidence that white holes exist. They are so far theoretical constructions, perfectly valid in Einstein's equations, but unobserved in reality. Yet some models suggest that black holes and white holes could be connected, like opposite ends of a tunnel, a wormhole perhaps, or a bridge between universes.
One theory suggests that what falls into a black hole in one universe might be expelled from a white hole in another, as if the cosmos were a grand recycling engine, passing information through folds in its own fabric. This is deeply speculative, and no one can say for sure if it reflects reality, but the fact that the math allows for such symmetry is compelling. The universe, in many of its patterns, prefers balance. Waves and troughs, charges and opposites, forces and counterforces. Maybe black holes are not just the end of things, but also beginnings. Strange beginnings, hidden behind veils we cannot yet lift. Even without invoking other universes, black holes are profound. They are not exotic footnotes to the cosmos, they are part of its scaffolding. At the center of nearly every galaxy, including our own Milky Way, there lies a supermassive black hole millions or even billions of times the mass of our Sun. They influence the orbits of stars, shape galactic structures, and perhaps even play a role in how galaxies form and evolve. In their darkness, they have power. In their silence, they have reach. What makes black holes especially beautiful, in a quiet, almost haunting way, is that they preserve a kind of memory. According to physicist Stephen Hawking, black holes may not destroy information after all. Through a process called Hawking radiation, they slowly evaporate, emitting faint particles over trillions of years. It's been suggested that hidden within this radiation, encoded in ways we don't yet fully understand, is a trace of everything that ever fell in, as if the universe, even at its most secretive, refuses to forget. So what hides in a black hole? Perhaps nothing. Perhaps everything. Perhaps the answer is not a location, but a principle. That at the edge of understanding there is always mystery. That some doors are not meant to be opened, but to be contemplated. That some silence isn't emptiness, but potential. As you lie there tonight, imagine drifting toward one of these cosmic thresholds, not falling with fear, but floating with curiosity. The stars thin out, the sky darkens, the gravity pulls, not like a claw, but like a lullaby. And then you reach the horizon, not a wall, but a whisper. You cross it gently, and beyond, no one knows. But maybe, just maybe, on the other side, there's light again. It begins like a whisper, a moment you've lived before, or at least it feels that way. You're sipping tea in a cafe, or stepping through a doorway, or reaching for a book you don't remember ever reading, and suddenly you pause. A strange stillness wraps itself around the moment. A thought stirs. I've been here. But you haven't. You couldn't have. Still, it lingers. Familiarity without a source, certainty without a timeline. This is déjà vu, a French phrase that simply means already seen, and yet it carries with it so much more than just visual repetition. It's a sensation, fleeting and uncanny, that a moment you are currently experiencing has somehow already occurred. And even though it lasts just a few seconds, it often leaves behind a ripple, not fear exactly, but a soft curiosity, a question that floats just beyond the edge of logic. From the perspective of neuroscience, déjà vu is most often explained as a kind of memory hiccup, an error in the brain's recognition system. Our minds are constantly encoding information, creating mental fingerprints of everything we see, hear, and touch. Usually, these patterns are sorted efficiently. New experiences are stored as fresh, and familiar ones are tagged accordingly. But occasionally, the sorting process stumbles. A current experience is mistakenly routed through memory circuits, making it feel like something we've already stored. It's as if your brain quietly nudges you and says, "You've done this before," when you haven't. Not here. Not now. Some researchers believe it's a kind of miscommunication between short-term and long-term memory systems. Others suggest it may be the result of slight delays between the hemispheres of the brain, causing a duplicated perception. Still, others have explored links between déjà vu and certain kinds of temporal lobe activity, especially in people with epilepsy, where similar sensations are sometimes reported just before a seizure. All of these explanations have merit. They're grounded in biology, in patterns of neurons and electrical impulses, but none of them quite capture the experience itself, the strange clarity, the weight of the moment, the eerie stillness that often comes with it. It's more than a technical misfire, it's an emotional echo, and that's where speculation begins to tiptoe in. Some have wondered if déjà vu might be more than a brain glitch, if it might be a kind of bleed-through, a gentle overlap between timelines. Perhaps in a universe where many versions of you exist, occasionally those versions resonate. A moment that one you has already lived finds its way somehow into your present, not as a full memory, but as a trace, a ripple, a familiar shape in unfamiliar water. Of course, this is not something we can test. There is no instrument that can detect a leak in the fabric between realities, no machine that can confirm where the timelines have brushed against each other like silk sleeves in a crowded room. But that doesn't make the idea any less evocative. There's something comforting in the thought that we are not entirely bound to a single path, that our lives may contain gentle shadows of the choices we didn't make. Imagine for a moment that each time you experience déjà vu, it's not an error, but a harmony. Two versions of you moving almost in sync, passing through similar spaces, thinking similar thoughts, their footsteps overlapping for a single instant, a kind of resonance across the multiverse. Not long enough to see each other, just long enough to feel that quiet click, that sense of having arrived somewhere familiar, even though all signs say it's new. Some people experience déjà vu only once or twice in their lives. Others feel it often, sometimes triggered by smells, sounds, or faces. And there are rare individuals who experience it persistently, sometimes tied to neurological conditions, sometimes not. For them, life becomes a series of mirrored moments, echoes upon echoes. They are like travelers caught between layers of memory, uncertain which version of events they're living. Science, cautious and methodical, tends to avoid multiverse explanations. It seeks answers that can be measured, repeated, confirmed. But human experience is not always so tidy. And so in the quiet space where measurement falters, imagination steps in. You might also consider dreams. How often do we find ourselves dreaming of places we've never been, faces we don't know, yet wake with the distinct feeling that something was remembered, not invented? Could dreams and déjà vu be connected? A kind of subconscious mapping of paths not taken, lives not lived. Some philosophers have even suggested that déjà vu might be tied to reincarnation or to inherited memory. Others, more metaphorically, view it as a kind of spiritual nudge, a reminder that life is larger than it appears, that we are part of something more layered, more interconnected than we can fully grasp. Perhaps the truth is simpler, or perhaps it's more complex than we will ever know. What matters for now is how déjà vu makes us feel. It interrupts the normal flow of time. It asks us to stop, to notice, to wonder. It reminds us that even in the most ordinary moments, there is room for mystery. So tonight, if you find yourself lying in the dark and recalling a moment that feels like it's happened before, let the sensation wash over you. Don't chase it. Don't try to explain it away. Just let it be what it is. A flicker across the surface of your story. A gentle crossing of timelines. A quiet echo from a life just out of reach. And if tomorrow you walk into a room and feel that strange pulse of familiarity rise again, smile softly. You've been here, and also, you haven't. Let's play a quiet memory game. Close your eyes, unless they already are, and picture a children's book you may have seen growing up. It's about a family of cartoon bears, kind-hearted and clumsy. The name almost certainly you remember as the Berenstain Bears. But what if you opened a book today and saw the name spelled differently? Berenstain with an A. You'd probably blink, then smile, then frown. You'd be sure it used to be A, not E, and yet the printed text insists otherwise. Not a typo, not a reprint, just the way it's always been. This is the Mandela effect, named after another misremembered moment. A large number of people, especially online, have reported remembering that Nelson Mandela died in prison during the 1980s. They recall vivid details, news footage, mourning crowds, a global reaction, but none of it happened. Mandela was released, became South Africa's president, and lived until 2013. These people aren't lying or exaggerating. They're simply certain they remember a world that doesn't seem to match the one we live in. And it's not just these two examples. There's a growing catalog of so-called Mandela effects. The Monopoly man never wore a monocle. Luke, I am your father, was never said in Star Wars. The Fruit of the Loom logo never had a cornucopia. Curious George never had a tail. These details feel so deeply embedded in memory, and yet they don't align with the official versions. Something feels off.
So what's going on? The most grounded explanation lies in the nature of memory itself. Human memory is not a perfect recording. It's a reconstruction, a weaving together of bits and impressions into something that feels coherent. Our minds often fill in gaps, smooth over inconsistencies, and align experiences with expectations. When many people share similar environments, media, or cultural cues, they can collectively form similar errors, shared misrememberings that feel like truth. Psychologists call this confabulation, the creation of false memories without intent to deceive. Combine that with confirmation bias, where we tend to seek information that supports what we already believe, and you have a recipe for group-level certainty built on shaky foundations. And yet, even knowing all this, the sensation remains. The wrong logo looks right. The remembered phrase still echoes. For most scientists, the Mandela effect is a fascinating case study in how culture shapes perception and how fragile our memory systems really are. But for others, particularly those who like to think just beyond the boundaries of what we can measure, it's something more. A possible hint, however faint, that we're not always rooted in a single timeline. What if, they wonder, the Mandela effect isn't about faulty memory at all? What if these moments are traces, residue from shifts between realities, a kind of glitch in the multiverse? Maybe in a parallel universe, the Bear family was spelled Berenstein. Maybe Mandela did die in prison. Maybe your mind remembers that version because in some way, not fully understood, you were once aligned with that branch of the timeline, and now, somehow, you've moved. Of course, there's no scientific evidence for this, no proof of timeline jumping, no instruments have detected reality shifting. But what this interpretation offers is something deeply human, a sense of hidden order, of meaning behind the oddness, a story that makes emotional sense, even if it's unprovable. And perhaps that's part of its power. In a world that often feels chaotic and unpredictable, the idea that these glitches are signals rather than errors offers comfort. It gives people a way to connect, to share their experiences and say, "You remember it that way too?" It's a kind of community, a modern folklore made from fractured memory and whispered possibility. We might think of it as a collective dream, not literal, not measurable, but shared nonetheless. A memory of something that never happened, held by many, a consensus of ghosts. It's easy to dismiss this as internet oddity, but consider for a moment how often we rely on memory to construct identity. Who you believe you are is built on a long chain of remembered choices, names, places, and faces. If even small pieces of that chain become uncertain, it can create a ripple of doubt, not just about the past, but about the nature of reality itself. And yet, perhaps that ripple is also a gift. It reminds us that our understanding of the world is never as solid as it seems, that perception is fluid, that time, truth, and memory are all things we build, not just things we inherit. Maybe the Mandela effect isn't a signal from another dimension, but a kind of poetic feedback from within our minds, reminding us that the world we experience is deeply shaped by the stories we tell ourselves. Still, the question lingers, soft and unresolved. Could there be other versions of this reality brushing up against ours? Could some trace of them slip through, not as portals, not as proof, but as feelings? And so, as you drift through these possibilities, let the thought settle gently. Every choice, every moment, is part of a vast and quiet mystery. If you found comfort in this journey, I invite you to subscribe and join us again. Share where in the world you're listening from. I'd love to know. For now, rest easy and let your mind wander softly among the infinite branches of the multiverse.